Okay, so one of the things, I'm out of line in the video, but one of the things I wanted to point out has to do with the minute to win, which is this continuity. One of the things I saw several times is that people are confusing a little bit f of x with the limit of f of x. Well, let me put it this way, f of c. Those are two very different things. This is the actual value. The limit could be a mess, it doesn't matter. This is the actual value. It might be there, or it might not be there. The way it's not there is if it's a whole or an asymptote. But otherwise, it's a point. It does not have to connect at all with, remember, limits are about behavior, so it does not have to connect at all to behavior. So these are really very different. Continuity means these two are equal. The limit does something sensible, and in the middle of that limit is the actual point. Okay, so continuity has to do with these being the same, but they need not be. So holes and asymptotes and gaps are places where that would not happen. Okay, so any questions that you want to go over? Or and also remember that on Blackboard I have clarifications file that I keep adding to. So please feel free to look at that. Those are just common mistakes that I see. So at some point I may stop writing on every assignment because I'm writing the same two sentences, so I just put it in the clarifications file. So I really recommend you look at that. So any questions on what was due today? Yes?
Number 43 on page 1.
Anybody else number 43? Yeah. Okay. Yeah, okay. So let's look at number 43. So number 43 was something like f of x, it was x squared plus x, is that right?
Yes.
And the first part was find the secant line from x equals 1 to x equals 3.
Yes.
To 3. Can I assume that everyone could do that one okay? That's just a matter of finding the y values, finding the slope, finding the equation of the line. I'm going to let that one go. That if you have trouble with that, come see me, because that's more previous. And then it said to find the slope, no, not the slope. Yes, slope between essentially x equals 1 and x equals 1 plus h. But the way it wrote it was this way. It gave you the points 1, f of 1, and 1 plus h, f of 1 plus h. Does everyone see that those are 2 points with the x value is 1 and the x value is 1 plus h? Okay, so those are just, so really this works exactly the same way as this. We just have to be careful getting the y values that go with it. And then c was find the slope of the tangent line at x equals 1. Okay, so we're going to leave A alone. Let's look at B. So for B, the first thing we need to do is we need to find our full point. So if x is equal to 1, y is equal to, did I get it right? 1 plus 1, 2?
Yeah.
Yes, thank you. One thing I found that was different is that normally I do a lot more back and forth with the class, and last time when I was taping, it was me talking, which I don't really like. So I'm kind of hoping that we can ignore that and just go back and forth kind of like I normally like to do. So our second point is this, x equals 1 plus h. So now I plug that in just like I always do to get a y value. So that will give me y, 1 plus h, quantity squared plus 1 plus h. Okay, so those of you who are looking at what the four-step method is for finding derivatives, this is kind of like that. The four-step method is to use the difference quotient. And the book lays it out as a four-step method. I don't call it that because you don't have to do that. You can go straight to sort of the last step right before the limit. You don't have to do each piece kind of separately. But it is laid out in the book as a four-step process to kind of help keep it straight. So here, now I have this y value, and this y value, this x value, this x value. So I can just make a slope. That's all I'm really doing. So I'm going to write this. Can we just write it this way? Just so that you'll see that it looks a little bit like the difference quotient. Right, that's kind of the same form. I'm saying the y value that goes with 1 plus h minus the original y value, the x value, and the x value. And this, of course, is h in the denominator. So that's this should look like the difference quotient to you. Okay, so let's start cleaning up this. So I'm going to FOIL out 1 plus 2h plus h squared. You should get good at writing it about that fast, because that's a pattern. So it's a perfect square. It's very important. In this case, we're just going to put the number 2. But whenever we have a general f of x, remember to use parentheses so that you get everything to cancel properly. 2 cancels with 1 and 1. So then altogether we get 3h plus h squared over h. Do some canceling. You can factor an h out of the numerator or realize that there's an h in every single one. As long as you take it from everybody, you're okay. So 3 plus h. So this is the slope between these 2 points. Why is that cool? Because part C is find the slope of the tangent line. The tangent line is what happens when these 2 points, x equals 1 and x equals 1 plus h, get really close together. Yes?
Okay, so how did you know to add the h right there instead of canceling it out?
Add the h right here.
Or, yeah, no, like,
Oh,
I mean
okay.
the 3, so to get the 3.
So if you factor out an h, this is what you're doing.
Right,
and that-
but I'm asking, like, so you added an h to the 2h, so how did you know, no.
So
Right,
when I put in,
lower.
here, so when I put in 1, so I'm taking x squared plus x, I'm putting in a 1 plus h everywhere I had an x. And then you just collect like terms. So if you get an h out of this one and an h out of that one, you combine them.
So I should have added the 2h plus the h instead of just canceling out that.
Well, remember, if you were to leave it this way, and when you were to cancel an h, you'd get a 2 left from this one, an h left from this one, and a 1 left from that one. Yeah, so remember that if you're pulling an h out of everything, it's a multiplicative thing. So h over h is 1, not 0. So that's why if you can't successfully, confidently, reliably go from here to here, go through this step, because this step will help get it right. Okay, so now when we're looking at the tangent line, now we're saying to find the tangent line at x equals 1, well, we can just use this. This is 2 points, 1 and 1 plus h. So if I let that h get really small, what have I done? I let my 2 points come down to 1 point. Tangent line is about 1 point. So secant is algebra, 2 points like usual. Tangent is 1 point, where the 2 points have come together. So all I really need to do is let h go to 0 here. So I'm just going to say this is equal to the limit as h goes to 0, 3 plus h. What do we always do first when we have a limit? The first thing we always try. Plug it in. So you plug in h equals 0. Do I have any more work to do? No. Regular number all done. Okay. So the connection here was secant is 2 points, that's algebra. This is still 2 points, but they're a special kind of 2 points that allow us to move using calculus to 1 point. Normally, I don't usually do it this way. I usually just use x's instead, and then just set x equal to 1 at the end. I kind of prefer to do it generally and then let x equal 1 at the end, but you can't put the 1 in up front like this one did and then just work through. Is that better?
I have a, oh wait,
Yes.
there's still a letter D. That's just,
Oh, what was D?
It was making like
The equation
for
of tangent line.
Oh, okay. Equation of a line. What do I do for the equation of a line?
y
Look how this low.
Slope and a
points.
point. It could be the y-intercept, it doesn't have to be. So slope and a point. So do I have a slope? Yes. Do I have a point?
You can choose
Yeah,
either.
1, 2. That's my original point, so now I just find the equation of a line. My preferred method is this one, but you can do the y equals mx plus b, find b, and rewrite. The reason I like this one is once I've solved for y, that is the answer. If you go finding the b route, you have to find b, and then remember to rewrite the whole equation. So there's one more step after that. So, did I do that right? Minus 3 plus 2, yeah.
Yes.
Okay.
yeah, I have questions on number 23 on page 143.
Okay.
For the f of x, I kept getting like negative 6x minus 9.
All right, so hang on a minute. So we have time for, let me look at that one. So I know there's a question on that one, and there's also a question on one of the word problems.
I have one like 85. If we have time.
Yeah, so what we may do is do sum of 23 and 85. I'm going to go with, tell you what, let's hold on both of those. I'm going to assume that number 83 was probably, when you have to do this the long way, when you have to find the derivative using the difference quotient, usually the mistake that's made is algebraic. So today we're going to, I don't want to belabor that too much. You need to know how to do it, but today we're going to look at how to do derivatives sort of the real way. So let's hold on that one, and we'll come back to it. And number 85 or 83?
I don't think we were supposed to do that one.
Oh, 85. Oh, yes, that's right, I delayed it for today.
Oh,
78, 79, and 80, and 85 were not supposed
okay.
to. But good as you do.
Yeah.
Yeah, so
Practice.
yes, all right, so let's look at what we're doing today. Today we are doing, all right, so let's review. What does f prime of x mean?
The derivative.
The derivative. So what does the derivative mean? What
Finding
is,
the instantaneous slope.
yeah, derivative is instantaneous slope. It's slope at one point. It would also make sense, you know, does everyone, so it's rate of change also. So slope, derivative, rate of change, those are all the same thing. So rate of change, velocity or speed is a rate of change. It's how fast your position is changing. So we know about instantaneous velocities. That's what your speedometer is going to read for you. So this is a derivative. So today we're going to look at how to find derivatives in a much easier fashion. So derivative is instantaneous slope, slope at a single point. So let me give you some notation. This is the one I've introduced so far. This means derivative. So does this. Because a lot of times we don't write f of x, we'll just write y equals something. So y prime also means derivative. I mentioned before that one of the things that we need to bear in mind for coming weeks is taking the derivative with respect to a particular variable. So usually for now it's x. So the way we make that clear is we can write d dx of f of x. This is a thing, f prime. That's a thing, that's a noun. D dx I like to think of as an instruction. This says take the derivative with respect to x of f of x. So I think of d dx as an instruction. Once you've done the derivative, this disappears and you write it this way. So verb noun, if you will. There's a similar one here where I would write dy dx. So all four of those are ways to write the derivative with respect to x. If we don't say with respect to x, you sort of assume it, just because, or if it were y of t, we would assume it's with respect to whatever variable is in the equation. Okay, so so we have a couple of rules. We'll start writing out some rules over here. I'm going to try and make a list over here so that I'm not standing in front of it when we need it. So here's the constant. There's a constant function rule. So if y equals f of x equals some constant, what will the derivative be? What do we say derivative means? Slope. Y equals c, what is that? What kind of shape is that?
Horizontal line?
Horizontal line. What is the slope of a horizontal line?
I mean,
Zero.
Zero. Always zero. Does it matter where the line is? Y equals pi, y equals negative 10 million, y equals 37 halves. It doesn't matter. It's a horizontal line. The derivative is always zero. So it's kind of handy. So if I have f of x equals pi, and I say find the derivative, you write 0. 0. Pi is just a number, 3.14. How many people know a lot more than that? 15926. That's all I got. Yeah, so that's 0. So just remember pi, any number, that's 0. Okay, here's one. We're going to work up to the power rule. So the power rule is going to be for functions that look like this. X to the n, x to some power. A polynomial is a combination of power functions. The power function is just the simple one, just x to the whatever. Okay, so let's, I'm going to give you, let's just back up for a moment. If I had this one, f of x equals pi, and I wanted to find the derivative the long way with the difference quotient. So I said the derivative is equal to the limit as h approaches 0 of f of x plus h minus f of x all over h. I start plugging in. What is f of x plus h? Is this ever anything but pi?
Can't be.
It can't be. It's always pi. So f of x plus h is pi. F of x is pi. So I'm going to get pi minus pi. Pi minus pi is 0. So I'm going to get the limit as h approaches 0 of 0 is 0. Okay. So what if, so I could do this, we've done this for some, right? We've had some homework assignments. So let's say that I had done that long-winded way, and I found these things. I started with f of x equals x, and I did it the long way, and that gave me this derivative. Does that make sense? That should be that derivative? What kind of a shape is this?
A line.
A line. And what is the slope of this line?
1.
Right? Derivative is slope. So does the slope of this line ever change? No. So is the derivative always 1? Yes. All right, so what about this one? This one is going to give you this derivative. Let's think if that makes sense. What kind of shape is this? Parabola. First, the slope is negative, and then it flattens out as 0, and then it goes back positive. So for negative x values, this is negative. When x equals 0, it's 0, and when x is positive, it's positive. So this describes the slope as it's changing for this. It's going negative, then horizontal, then that. Yeah, that's just me. Yeah, my basement flooded over the weekend, so we'll come back to that. Okay, so what about this one? Let's think about if that makes sense.
Is dropping ahead on this.
What's that?
So I got,
Again, did you predict? Yes. Almost there yet. Almost there yet. Yes, you're absolutely right. So let's make sure this makes sense. This is saying the slope is 3x squared. What do I know about x squared? It's always, any square is always positive, right? So this is saying the slope is always positive. Is that true? Positive, positive. It tapers down and goes through 0. Does that make sense? Yes. When x is 0, that slope goes through 0. So looking at this and the graph, they make sense together. Okay, let me give you one more, and then Alan can say what he was going to say. So all of these, somebody did the long way. And it's a pain. We don't want to do these the long way, do we? Do we want to raise x plus h to the 4th power? No, we really, really don't. Okay, so what do we think? Are we seeing a pattern here? What is the pattern?
so you would just move that exponent to the front and then do n minus 1.
Yeah, so I take this exponent, I move it down front, and drop the exponent by 1. That's correct. So the way we would write that is f prime is n times x to the n minus 1. So whatever the exponent is, drop it down in front, and then reduce the exponent in the exponent location by 1. Anywhere in here, in this rule, do you see any limitations on n? Does n have to be an integer? Is there any, no. Does n have to be a positive number? No. So n can be anything here. This actually works for all n, not just for these nice ones that are easy to figure out, but it works for all of them. So let's do a bunch of examples. So that's for any n. All right, so here's what we're going to do. I'm going to give you several. And I'm going to give you some different notation too, just to kind of reinforce that. So here's example 2. Did 1 was f of x equals pi, for those of you who are keeping track at home. Y equals f of x equals x to the 7th. Find dy dx. Y equals x to the 2/3. Find y prime. 4, y equals 1 over x squared. Find f prime of x. So think about what you want to do with this. When you get down to this last third one, you'll need to do a little work before you can start the derivative.
For the first one, couldn't you just use the same rule we just did?
All of these use the same rule we just did. Yep, that's why I left them up there. How's everyone doing? First two done, working on the third? Yeah? All right, let's look at the first two. So the first one, this should be a walk in the park. This one's pretty easy. After you do about 3 of these that are this simple, you don't even think about it anymore. So we just bring that 7 down in front. 7 minus 1 is 6. So dy dx says find the derivative. Okay, what about this one? Y prime, what are we trying to find? Derivative. So same thing. Take this, bring it down in front, 2/3. In front, up here in exponents, you'll often see me use slashes. Do not ever use slashes anywhere else. Do not write this as 2/3, because then it's not clear whether what follows is in the denominator or not. So write it as 2/3. Additionally, never write, I know they've taught you for many, many years that this is improper form. Actually, that's proper form. I mean, this is the way you have to write it from now on. You cannot write 1 2/3, because you don't know if it's 1 2/3 or 1 times 2/3. So we always write all of our fractions this way, top, bottom. So 2/3, x to the, what's 2/3 minus 1? Negative 1/3. Okay, so that's fine. I mean, that's okay. You're going to get negative fractions. You're going to have that in assignment, so just be ready. Okay, so now let's look at this last one. 1 over x squared. Is that the form here? This is x to the n. Is it 1 over x to the n? No. So I cannot do it the way it's written. You have to rewrite it. That's why I was trying to do the first day and kind of botched the instructions. I need to write this as x to the minus 2. Now is it in the right form? X to the n? Yeah, no problem. So negative 2. Negative 2 minus 1 is 3. Yeah, I gotta make that. That's what we need to make sure. Yes. Okay. So is this okay? So the big thing here is that you just need to make sure to rewrite anything that's in the denominator this way. Let me give you one more. Yeah. Well, I have many more, but I'm going to give you one more right now. What about this one? Oh yeah, I did. The same hint as the previous one. You have to write that with x in the numerator. So we need to remember what cube roots, how to rewrite those. So this is a 2-part. This one just had to pull it out of the denominator. This one's got to rewrite the root as well. So how do I rewrite cube root of x? x to the 1/3, and then when I pull it up into the numerator, I get x to the negative 1/3. I cannot take the derivative like this. I have to do it. I have to write it this way because that's what my power rule refers to. So now the derivative is easy. Bring it down in front in all of its negative fractional glory, and then subtract 1. So negative 1/3 minus 1, negative 4/3. Okay, so that's an important part. The power rule only works, is only defined for x in the numerator. Okay, so now let's look at some other general rules of derivatives, which are, I actually don't even like to list them. Well, I guess we'll list them. I don't usually write them out very formally. And they pertain to limits. So what works with limits works with derivatives and works with integrals when we get there. So if I had this, I can plug in 2 into both places, right? The addition sign carries through. I just write addition carries through. I just plug into both pieces and that's my answer. So addition carries through. What else carries through? If this were a minus sign and I subtracted, would that carry through? I would just subtract, right? I would plug in and just subtract. Subtraction doesn't affect anything. I just keep going. So subtraction carries through. This 3 on the front of the x, is that a problem? Or do I just multiply the 3 times the 2, right? Multiplication by a constant carries through. X squared is really x times x. Is that a problem? So really any multiplication carries through. So these are all, what's the word I'm looking for? Escape me. These are all things that you can do that don't, they just carry through. You just keep on right on going. What would not carry through? What would cause a problem potentially when you're trying to compute a limit? Yeah, I can add, subtract, multiply by a constant, multiply by anything really. Square roots, yes, and division, yes. So these carry through. Division, no, right? Division can cause some problems. So we should say always carries through. So this set, always, never a problem. Division, that can cause a problem, so that's going to be separate. And actually multiplication, you know what, I'm going to take this one off. Multiplication is going to be separate too. So division, division and multiplication, change it this way, are going to cause some problems for derivatives. And then also square roots. Okay? So addition, subtraction, multiplication, they just carry through, no problem. Okay, so these 3 carry through, so let's do several examples. And another way to write that, if you want to get all right, so here are here's how you would write it formally. The derivative of any constant times a function. So I multiply any function by a constant. That's just the constant times the derivative. So that's kind of the formal way of writing it. Same with addition. The derivative of 2 functions added is the addition of the derivatives. Okay, so the derivative, so I'm just going to write it this way just so we have a list. F minus g plus or minus g is f prime plus or minus g prime. So addition, subtraction, multiplication by a constant carry through. So let's do a laundry list of examples. All right, so f of x equals negative 6 x to the 5/3, and f of x equals 5 over 3 x cubed. You'll find the derivative for both.